when we're trying to solve a systems of nonlinear equations, we have to be pretty darn exact when we graph our parabola. You don't have to be as exact with the inequalities because we're looking for a range of answers. So once again, I'm still using my negative b over 2a. So that becomes negative 4 over 2 times 1. So right away my x coordinate is negative 2 for my vertex. And I'll put that on the side here. When I plug the negative 2 in, we get negative 2 squared plus 4 times negative 2 minus 1. 4 minus 8 minus 1 is a negative 5. Oops. So my vertex is negative 2, negative 5. Negative 2, negative 5. And here, I'm going to plug 0 in for x and get negative 1. And then 1, 2, 1, 2. Obviously, the other point is going to be negative 4, negative 1. Now, that's enough to draw my parabola. And keep in mind, the parabola has to keep going out. Can we agree that means 0, 0 has to be inside the parabola? If you're someone who always wants to use 0, 0, you always just have to treat your parabola as always going wide. Now, it's a less than, so this is going to be a dotted line. I don't care which point you choose as long as it's not on the parabola. Most people like to choose a point inside the parabola. So I'll use negative 2, 0. Although I used other examples with other students. If I plug negative 2, 0 in, okay, we get 0 for my y is less than negative 2 squared plus 4 times negative 2 minus 1. 0 is less than 4 minus 8 minus 1. 0 is less than negative 5. Can we agree 0 less than negative 5 is a false statement? Yup. Which means wherever that point is, if it's inside the parabola, we shade where it's not. So in this case, the shading is outside the parabola. If you wanted to verify it, pick a point outside the parabola. 1, 2, 3, 4, 5. 5 zeros should create a true statement. 5 squared is 25. 4 times 5 is 20. 25 and 20 is 45. Minus 1 is 44. 44 is clearly greater than 0. Okay, so you can verify that you're... Once again, I'm going to use negative b over 2a. And I'm going to get negative 8 times 2 times... or negative, and then 8 over 2 times the negative 2. We have two negative signs. So this becomes a positive 2. Negative 2 times 2 squared plus 8 times 2 minus 3. Negative 2 times 4 plus 8 times 2 minus 3. So that becomes negative 8 plus 16 minus 3. That equals 5. All right? Kind of coincidence, we just kind of got to the 5 of those 5. So my vertex here is 2, 5. And I'm going to plot that point. 2, 1, 2, 3, 4, 5. 0, negative 3. Which means, by my line of symmetry, 0, negative 3 is here. 1, 2, 1, 2. 0.4, negative 3. It is a dotted line. And since this is the point of intersection, 0, 0 is not in the parabola. I'll use 0, 0 for this one, but 0, 0 is clearly not in this parabola. So now, 0 is greater than negative 2 times 0 squared plus 8 times 0 minus 3. Those are all zeros. We're left with 0 is greater than negative 3. I would argue that's a true statement. Where's the 0, 0? It's outside the parabola. And it's true. So where do I shade? Outside the parabola. If I wanted to verify, pick a point inside. 2, 0 better make a falsehood. 2, 0 better make a false statement. Negative 2 times 2 squared is negative 8. Plus 16 is 8, minus 3 is 5. I think we can all agree 0 is not greater than 5. Not a true statement. So therefore, it's false. There's no shading there. It's not we shade outside if it's true, or we shade inside if it's true. We shade where the true point is. That's really how you have to think of it. So once again, we're using our negative b over 2a. All right, so down here, we're going to get negative 4 over 2 times 1, which I believe is a negative 2. I don't believe it. I know it is. Okay, and then we plug in. And we don't have to worry about the inequality signs when we're trying to find the points for our vertex. Hold on one second, guys. Minus 1. So we're looking at 4 minus 8 minus 1. And we're looking at negative 5 here. Okay. So my vertex is going to be negative 2, negative 5. I have a point of 0, negative 1. So when I do this, negative 2, 1, 2, 3, 4, 5, 0, negative 1. And then if I draw my little line of symmetry, 1, 2, 1, 2. So point negative 4, negative 1. And that's really enough to draw my parabola right now. Okay? It is a greater than or equal to, so it is a solid line. Okay? Now I come to the bottom of it. Negative 4, negative 2. And the negative out in front here means my answer is going to be negative. It's going to be a negative 1. And then I plug negative 1 in. Negative 2, negative 1 squared minus 4 times a negative 1 plus 5. Negative 1 squared is 1 times negative 2 plus 4 plus 5, we get 7. So my vertex is negative 1, 7. So I'm going to plot that point. Negative 1, 1, 2, 3, 4, 5, 6, 7. All right. Now, 0, 5 is a point. Do your little line of symmetry. Over 1, I'm going over 1 this way. There's another point at negative 2, 5. This is a dotted line. And you want to extend the lines long enough that you are intersecting them. Now we go to our shading. My advice here is this. 0, 0 is in both parabolas. 0, 0 creates a true statement on the top. 0 is greater than negative 1. So that means we shade inside. 0, 0 creates a true statement in the one opening down. 0 is less than 5. So when we shade down, we're going to be inside. Okay? And this right here is my double shaded region. And that's what you want to establish. You want to establish the double shaded region. Okay? Any questions with that one? Second one, same deal. My vertex, negative b over 2a. So we have 2 over 2 times 1. And it's always a negative in front of that fraction. So that ends up being a negative 1. Negative 1 squared plus 2 times 1 minus 2. That's 1 plus 2 minus 2. We get 1 there. So my vertex here is negative 1. Oops, hold on, I made a mistake here. Yikes. This should be a negative 1 right in there, my bad. Let's fix that. So this is 1 minus 2 minus 2. We should get a negative 3. So my vertex is negative 1, negative 3. Negative 1, negative 3. 0, negative 2 is 1 point. Do that line of symmetry, and I go over 1 this way. So it's point negative 2, negative 2. That's enough to graph, and it should be a dotted line. Means it's a greater than sign. Second one, negative 6 times 2 times negative 3. That's a positive 1. And then negative 3, 1 squared plus 6 times 1 plus 2. That's negative 3 plus 6 plus 2. That gives us 5. So this graph, the vertex is 1, 5. 1, 1, 2, 3, 4, 5. Plug your point in. 0, 2. And it's going to be 2, 2. We draw that line of symmetry, 0, 2, 2, 2. This is going to be a solid line because it's less than or equal to. Now in this graph, 0, 0 is inside of both graphs. 0 is greater than the negative 2. Therefore, we shade inside. 0 is less than 2. Therefore, we shade inside. It's this double shaded region. That's our answer. So on the problem where the instructions say use Desmos, you're literally going to type both equations into the Desmos calculator. So when I do that, let me type those equations in real quick. We're doing x squared plus 7x plus 1 and negative 2x squared minus 5x plus 2. Your answers are literally this. Where is the point of intersection? 0.082, 1.578. 0.082, 1.578. Come down here. Negative 4.082. Negative 10.912. That's it. So in this case, x plus 2 times x minus 1. That's exactly how you type it in. X plus 2 times x minus 1. Oops. And that'll give you your first graph. Sorry, we got to bring the graph back to the middle. And then the second graph, negative x squared minus 6x minus 1. Negative x squared minus 6x minus 1. Here's 1 point of intersection, 0.137, negative 1.844. 0.37, negative 1.844. And then the second point of intersection, 0.137. And that second point of intersection, we come up to here, click right on it, negative 3.637. And then we include our y coordinate on there, 7.594. 7.594.